So far we've covered central angles. A central angle is an angle whose vertex is the center of a circle. To find the measure of a central angle, we need to find the measure of the intercepted arc. The measure of the central angle is equal to the measure of the intercepted arc. The second type of angle we looked at was an inscribed angle. An inscribed angle has its vertex on the circle. And if you notice, when we take that vertex and we stretch it out to be on the circle, our angle gets smaller. So the measure of our inscribed angle is going to be smaller than our central angle. How much smaller? Well, it's exactly half the intercepted arc. We're going to look at two more types of angles today. The first type of angle is where that vertex has been stretched to the point where it's outside the circle. We still have an intercepted arc, but now our vertex is outside the circle. When that vertex moves outside the circle, our angle gets smaller than our inscribed angle. How much smaller? Well, we've created another intercepted arc. I'm going to call that intercepted arc CD. The formula for an angle where the vertex is outside the circle is 1/2 times the measure of our big intercepted arc minus our smaller intercepted arc. Which makes sense, since we are subtracting, we're getting smaller than this inscribed angle. The fourth type of angle that we're going to look at is an angle whose center is inside the circle but not a center. That angle has to fit somewhere between our central angle and our inscribed angle. So its measure is going to be between those two values. We're going to still use 1/2, and we're still going to use arc AB, but we need to get bigger than this angle here. So how do we get bigger? Well, we're going to add another arc. How do we get that other arc? Well, I'm going to extend AB to make it a chord. And I'm going to extend BP and make it a chord. So I have a second intercepted arc. So our last two angles, our vertex are outside the circle and inside the circle. The formulas are very similar, except for in one we're subtracting and the other we're adding. Let's look at example 1. Example 1, we are solving for x. X is this angle whose vertex is on the circle. So we have to look back at our formulas and figure out which angle has the vertex on the circle. And we look, and it's this angle. So our formula that we're going to use is angle equals 1/2 times the intercepted arc. The intercepted arc in this case is this arc right here. Now we don't have that measure, but we do have the measure of this major arc. We know that this major arc is 250 degrees and the entire circle is 360 degrees, which means that this intercepted arc has to be 110 degrees. So the measure of our angle is going to be 1/2 of this arc, since its vertex is on the circle. Angle equals 1/2 times arc. Doing that math, we get x equals 55 degrees. Example 2. Our angle is inside the circle, but not a center. So the formula we need to use is this last formula. Angle equals 1/2 arc plus arc. In this case, the two arcs that make up this angle are this arc and this arc. If this angle is 120 degrees, we know how big this angle is, it's 60 degrees, and we know how big this angle is, it's 60 degrees. We know how big this angle is, it's 120 degrees. But let's focus on this angle right here. Our formula is going to be angle equals arc 1/2 arc plus arc. Angle, 120 degrees, is going to equal 1/2 times arc plus arc. Our two arcs are 210 degrees and x. Now we need to solve for x. Step 1, distribute. Undo what's happening to x. To undo 1/2 times x, I'm going to multiply both sides of my equation by 2. My final answer is x equals 30 degrees. Last example, example number 3. Locate the vertex of the angle. The vertex is outside the circle, so the formula that we're going to use is our third formula. Angle equals 1/2 times big arc minus little arc. My little arc is easy to see. It's x big. What's tougher to figure out is my big arc. To figure out my big arc, I need to realize that my entire circle is 360 degrees. And if my little arc is x big, to solve for my big arc, I'm going to have to take 360 degrees and subtract off whatever this value is. In this case, my big arc is going to be 360 degrees, the measure of the entire circle, minus x. So my formula is going to be angle equals 1/2 times big arc minus little arc. Angle equals 1/2 times big arc minus little arc. My little arc is x, and my big arc is 360 degrees minus x. Once I have my equation set up, I need to do algebra to solve for x. Step 1, simplify what's inside the parentheses. I can combine minus x into minus 2x. Now I can distribute. Undo what's happening to x. Divide both sides by -1, or I could multiply both sides by -1, and I'm left with x equals 140 degrees. So if x is 140 degrees, that means that this arc is going to be 360 degrees minus 140.